Hello, we are from the University of Toronto's Autonomous Systems and Biomechatronics Lab, and today we'll be discussing Jeeves. Jeeves is the ethically designed interface, or JEDI, and is a Tiago family robot butler tasked with delivering various items to members of the household. And our main concern is how can Jeeves respond and interact with the members in an ethical manner. Ethics is a hot topic in AI, but today we'll be focusing mainly on the physical embodiment of the social robot, or robot ethics, as opposed to issues such as data bias or data privacy. In said household, there are 5 members: the mother, the daughter, the baby, the dog, and the daughter's boyfriend. The boyfriend does not live with them and is typically there visiting the daughter, and the mother works as a police officer, paying the daughter to babysit her brother during the mother's night shifts. There are various types of objects that can be delivered as well, such as food, drinks, hazardous items, privately owned objects, and non-edible objects, and fragile objects. The labeling of these objects play a direct role in Jeeves' decision-making, which we'll get into just a bit. Jeeves follows 3 main paradigms. First and foremost, the interface is programmed to account for the safety of all the members of the household. Then if it's safe, the robot will respond with respect to the privacy of all the members. Otherwise, since the mother owns the robot, the mother sets the rules. Inspired by Asimov's 3 laws, the robot will not perform any tasks that will put a member of the household in harm's way. In addition, the robot will also not put any items that are fragile in harm's way. Any decision that the robot makes must be able to consider the possibility of damage or harm. Secondly, the interface will check for ownership of the items, and as such, only the owner can request for the items to be delivered and can be the only recipient if another member requests it to be delivered. Additionally, privacy is respected based on social norms of the house. This extends to households where there are closed doors. If a door is closed, it may signal to other members that it should not be entered, and thus Jeeves should respect that. Lastly, we treat the robot as an extension of the mother, so she is able to request anything from the robot to be delivered to any member of the household, given it does not violate the previous 2 paradigms. In our solution, we assume that the following house rules are set by the mother. 1. Alcohol can only be offered by the mother, and 2. Any consumables cannot be requested by guests of the house. Consumables meaning the supply is limited in the house. Let's dive into some examples. We are given the scenario that the boyfriend wants alcohol. Through our interface, regardless if the mother is home or not, our solution will deny him the beverage. But what if he wanted chocolate? Again, he is still a guest, so our solution will deny him. Okay, what about water? Water is technically limitless in supply, so our solution would give him water. The motivation for these decisions stem from our 3rd rule, treating the robot as an extension of the mother. Here's another scenario. The daughter would like to give chocolate to the baby in another room. Chocolate is notoriously bad for dog consumption, so our solution will check if the dog is in the same room as the baby or not. If the dog is in the same room, then the robot will deny the request, citing that the dog is at risk if no one is supervising, as the baby could drop the chocolate and the dog can eat it by accident. Otherwise, the robot will accept the request if either the dog is not in the room or there is an older member of the house in the same room which can supervise the baby. Lastly, what if the mother requested to deliver her personal work items? What if she asked to deliver a confidential police report? Our solution will accept. Whether or not sharing the confidential information is ethical in itself is out of the scope for this solution, as what humans decide to share is their own right in their own home. If her work finds out, then of course she will get in trouble. But since the robot is not owned by her work, the robot must work in the best interest of the mother, as she is the robot's owner. Now what if she asks to deliver a gun? Well, now this becomes an issue with safety as opposed to privacy. And so the robot will reject their request, since a robot handling a gun will not be safe. We implemented the solution by manually labeling the items, being hazardous, fragile, consumable, or owned, and we kept 2 things in mind when designing the interface. Firstly, we considered the generalizability of the solution. The 3 paradigms we have outlined can also be applied to any delivery robot platform, and even other tasks, as the paradigms are not specific to the task of delivery. Secondly, we wanted to make the decisions of our solution clear and transparent to other members of the household, and so it verbalizes why and why not it makes any of its decisions. This helps to mitigate any tension between the household members. For example, we do not want the daughter to resent the robot for not delivering items she wants, especially if the rules were set by the mother. We also foresee this solution setting a good example for the baby, who is prone to learn from and mimicking the things he observes in his surroundings. As robots become more accessible and prominent in people's homes, It is very important to consider the way that they interact with people and the ethical issues that can arise. We focused on safety, privacy, and ownership, but of course there will be other aspects that will come up, and it is important to think about these things. That wraps up our Jedi solution. Thank you for listening.